So in this video, we're going to discuss how to find the volume of prisms and cylinders and spheres in different shapes. Okay, so when you think about volume and capacity, we don't often sit down and figure out exactly how much volume is going to go into it or how much of something is going to go into a certain object, but we do estimate very regularly. And there's just a few examples here, but you kind of think about, you take a can of soup, you want to cook a can of soup, you got to figure out, is the pot that I have going to hold it? So you sort of look at it, ballpark it, say, yeah, it's going to hold it. Same thing with fitting something in the back of your car. I used to work at Canadian Tire a long time ago, and I used to have the job of trying to fit things into people's cars, and sometimes they weren't very good at estimating what was going to fit. So they'd buy barbecues and bring a little Ford Fiesta or something and expect that it was going to fit. So we had some issues with estimating, but you do that fairly regularly. Okay, you look at a certain object and you say, what is the volume of that object? Now, you're pretty good at estimating some of the time, but we want to actually find exact values. So what we're going to do is we're going to talk about how to do that. And we're going to talk about a couple of different objects. Okay, so there's 4 of them that we'll discuss, and they each have different formulas. So rectangular prisms, we're going to start with that one, and the volume is just length times width times height. And I'll just show you an example. Here's a rectangular prism. Okay, so the volume of this would be, the length is 9, okay, because it's the distance from here to here. So the length is 9, and then times the height and the width. The width is 3 along the bottom, and the height is 3. So we get 9 times 3 times 3, and that gives me 81, which is really just 9 times 9, okay? And it's meters cubed, it's cubic meters. So every time you have a volume, the unit is cubic meters. So there's a rectangular prism. Okay, then we have a cylinder. Okay, now a cylinder has 2 variables or 2 parameters you need to know, the radius and the height. So here, this is the height is 6, okay? And down here, you have to be able to figure out the radius from the diameter. So you notice the diameter is all the way across the circle. A radius is half of that. So if the radius is what I need, then I have to take half of what I'm given. And I'm given 2 as the diameter, so the radius is going to be 1. So then the volume becomes pi times 1 squared times 6. And that gives me 6 pi, all right? Again, in cubic meters. Now you might, if you want to take your calculator, you can do that, and I'll show you what it looks like if you do that. You can multiply 6 by pi. So I can go 6 pi equals, or maybe times 6, I guess. There we go. Is 18.85, let's say. All right. So we can write it as 18.85 cubic meters as well. And you'll notice pi shows up in the cylinder formula, in the cone formula right there, and then also in the sphere formula right there. So you can either choose to leave it as a multiple of pi or just multiply it out. And most of you, I assume, are just going to multiply it out. Okay. Now we have a cone. A cone also has a radius and a height. In fact, you'll notice, hopefully, that a cone is just a third of a cylinder. We just take the cylinder formula and divide by 3. So we're going to do the same thing here. We're going to have volume as pi times r. Now r, because we're given this to 6, right, the whole distance, then the radius, which is from here to here, is half of 6, so it's 3 meters. So we're going to go 3 squared and then times 9. So that's going to give us 81 pi, which is approximately, and then we're just going to go to our calculator and go 81 times pi. And it's 254.5. Okay. Now, what's interesting about a sphere is a sphere only actually has one variable or parameter that we need to know, and it's the radius. So we're given the radius here, it's 1.7. So our volume for this is just 4 times pi times 1.7 all cubed divided by 3. So this one we're just going to do directly on the calculator. And I'm going to take 1.7 and I'm going to raise it to the 3rd power first. Okay. Then I'm going to multiply it by 4 and multiply it by pi. That's the whole top piece. And then I'm going to divide my answer by 3. And I'm going to get 20.6. And in this case, you'll notice it's feet is the unit, so this is going to be cubic feet. The feet with a 3 on it. All right, so that's how you do the volume of each of these. Okay, if we look at these, it's the same kind of idea. All right. Now, in this case, we've got a cylinder, a cone, a sphere, and then the first one's a rectangular prism. They're sort of underneath each one. You have to be able to identify which one it is, but I think they're fairly distinctive shapes. So it's fairly obvious that that's a cylinder, that's the rectangular prism, and so on. Okay. So the volume of this guy is going to be length, width, and height. So you basically need those 3 dimensions. So they're 6, 6, and 5. So that's going to give us 180 cubic centimeters, all right? Because 5 times 6 is 30, times 6 is 180. The volume of the cylinder is pi times r. In this case, we're actually given r, all right? So we don't have to take half of it. So it's just 3 squared and then times the height, which is 10. So that gives me 90 pi, which again, you could do on your calculator. Excuse me, is 282.7. And in this case, the unit is inches, so it's inches cubed. For the cone, the volume is pi times r. Again, we're given the radius here, not the diameter, so we don't have to worry about it being half, and then times 12, and we're going to divide the whole thing by 3. Okay? So if we do that just on our calculator, I'll just show you. We go 6 times 6, that's 6 squared. Then we times that by 12 and times it by pi. Okay, and then we divide our answer by 3, and we end up with 452.4. So we'll do that, and it's cubic yards in this case. And then finally, the volume of a sphere is 4 pi times r cubed, so 9.5 cubed, all divided by 3. So our volume here is going to be approximately, grab our calculator again, and we're doing 9.5 cubed first, and multiplying it by 4, and then multiplying it by pi, and then dividing our answer by 3. And I get 3,591.4. And that is in cubic centimeters. Okay? So that's the idea behind finding the volume. And what I want you to do, we're going to give you a few questions. I'm going to leave some questions here. This is sort of for you to try. Okay? So I'm just going to scroll through them slowly. You can pause the video and try them on your own, and you'll get your answers from your teachers. So there's question 1 and 2, both cones. Okay, these are both cylinders. They're just sideways. This one is. Okay, so it looks a little bit different, but it's still a cylinder. The height is 9, though, and the radius is 12. So just be careful with that one. And then these are 2 rectangular prisms. And then this is a cone, okay, sphere, and then a cylinder and a rectangular prism. So you can try those on your own. However, what we want to be able to do is actually apply these to certain situations. So here's a situation where we have different fish tanks, okay, 3 different fish tanks, and we want to know what is the volume of water that these things can hold. How much water will they actually hold? So the volume is going to be length times width times height, right? Because they're all rectangular prisms. In the first case, it's 60 by 20 by 20. In the second case, it's 40 by 20 by 20. And then in the third case, it's 20 by 20 by 20. So all we're really changing is the length, right? 60, 40, then 20. And all we have to do is expand them. We just have to multiply them together, okay? So we're going to get 24,000 cubic centimeters, 16,000 cubic centimeters, or 8,000 cubic centimeters. Now, 1 liter is equal to 1,000 cubic centimeters. Because you look at this, you think cubic centimeters, what does that mean? We're used to volumes being in liters. So all we're going to do is divide each of these by 1,000 to do a unit conversion into liters, okay? So that means that this is just going to be 24 liters, because essentially all we're doing is canceling out these zeros, right? They're dividing out with these zeros. You're going to get 24, you're going to get 16, and you're going to get 8, okay? But you'll notice we converted the unit. So now instead of cubic centimeters, we're saying liters. All right? Here's another example. So a tennis ball, it says, has a diameter of 6.7 meters. And I want to know what the volume of the tennis ball is. So the first thing I have to consider is, what is the shape of a tennis ball? And it's a sphere. Now, it's probably not a perfect sphere. It has those little lines in it that are grooved, and so it's not exactly a sphere, but it's close enough. So in order to find the volume of the tennis ball, we're going to use the volume of a sphere. But the volume of a sphere formula uses r, right, the radius. And this gave us the diameter, okay, not the radius. So we have to take half of that 6.7. And if you do that, you get 3.35. Okay, and then you put that into your formula, and you'll get a volume. It comes out to about 157.5 or 157.48. Now, what's interesting, if you've ever bought tennis balls, is they normally come in a cylindrical tube, and there's 3 balls in the tube. So we want to know what's the volume of that container. So if we think about the way it's drawn, it's a cylinder. The balls are inside, so they're sort of stacked on top of each other. Okay, and this is the container. So it's a cylinder. It has a radius the same as the tennis balls. Okay, I haven't drawn it as nicely as I would like, but the tennis balls are touching the outside. So it has a radius the same as the tennis ball. So the radius is 3.35. And then the height is going to be 3 tennis balls with the full diameter, right? All the way down, all the way down, and all the way down. So we're going to get our radius to be 3.35 and our height to be 20.1. 3 times 6.7. And then we just fill that into our formula. So our formula says pi r squared h. So we know r is 3.35 and our height's 20.1. So we just plug those in, and then you just take your calculator out and find the answer. And I would suggest that you do this on your own. I'm getting 708.66 cubic centimeters. Okay? But it's important that you get that as well, because you need to be able to use your calculator, especially with the pi. Sometimes that throws people off, so just make sure that you're using your calculator and checking to get those answers. Hopefully that makes sense. We'll do one more contextual problem. Okay, so here's another problem, and it's a lot of words, but basically what it says is, when you take granular material like sand, gravel, or grain, and you may actually have seen this if you live in St. John. On the west side of St. John, there's a pulp and paper mill, and the wood chips come in and they go up along these exact same sort of elevator here. You'll actually see that happen sometimes. But what happens is that it comes off this conveyor belt, it actually forms a cone. And it says the angle between the horizontal surface and the slope of the pile is called the angle of repose. And the angle of repose, it says, stays the same regardless of what height the pile is. So the first thing it asks us to do is, it says a gravel pile in a maintenance yard has a diameter of 3.5 meters and a height of 1.2. What's the volume? So it's a cone, right? So that means we need the radius. If you look at our formula, we need the radius, and then we need the height. It gave us the height directly, right? The height's 1.2. So that's our height. That's h. The diameter is 3.5. That doesn't tell me the radius directly, but half of that is the radius. So the radius is going to be 1.75. It's half of 3.5. So there's my dimensions. Okay, height's 1.2, radius is 1.75. So I plug it into my formula, which is pi times r, 1.75 squared, times our height, which is 1.2. And then we just divide it by 3. So again, take your calculator, please. Make sure that you can get that same number. Okay. Now the question says, what will the volume be if you double the dimensions? So if we double the dimensions, that means our radius becomes 3.5 and our height becomes 2.4. And what happens, again, is we plug into our formula, and we're going to end up with a much larger number, 30.8. Now it's said to use proportional reasoning, and you can kind of think about this. If you double this, 2 squared, okay, because I'm doubling this number, so I'm going 2 times 1.75. So 2 squared and then another double here times 2, that's actually 8, right? So if I take 8 and multiply it by 3.85, I'll get 30.8 as well. So you can kind of look at it as a proportion. In other words, if I double the radius, I'm actually multiplying by 4, 2 squared. And if I double the diameter, or the height, sorry, I'm multiplying by another 2. So I'm multiplying this volume by 8 to get that volume. That's another way of looking at the question. But you can just find the volumes and then divide them and get your scale factor or your proportion, which is 8. It's 8 times as much. So that's the idea of volume. And basically, you're just going to practice finding the volume of spheres, cones, cylinders, and rectangular prisms. And the reason we choose those, if you're wondering, well, why those 4 shapes? One reason is because the formulas to find them are relatively simplistic. And the other one is that those are fairly common shapes. You see those shapes all over the place. All right, cylinders, you see cylinders all the time. You see rectangular prisms all the time. If you've been ordering from Amazon anytime recently, they all come in boxes. And you think if you ever open the box, they're not very good at estimating what the volume is inside the box because usually there's a lot of empty space. But you'll see those boxes are all rectangular prisms. Okay, cylinders. Anything that's a pipe is also a cylinder, so you can kind of think about volume of liquid that might flow through a pipe. Those kind of things, it can all be considered to be cylinders because they're rounded or they're sideways cylinders and they're not necessarily cut off at one point or another. But you can find volumes of a stretch of pipe. You can find volumes of cones. If you've ever taken those little water coolers, the little cups that come in them, they're in cones. Okay, if you see water towers. Often the water tower has a conical bottom to it, so it allows you to pour the water down and out of it, or silos, those kind of things. So you'll see a number of different examples in real life of these kind of shapes, and that's why we're using those. So hopefully that makes sense. You'll have some practice given to you by your teacher, and that's how you find the volume of those shapes.